இது ஒரு 2 செகண்ட் ரெக்கார்ட் ஆகட்டும் முதல்ல.
ரெக்கார்ட் ஆகிட்டு இருக்கு.
இப்போ start.
Welcome to the session on Introduction to Transportation Models. Already we have seen in the first unit about the linear programming problem. The extension of that we are going to see about transportation model as unit 2. So what is a transportation problem? Transportation problem is a special type of linear programming problem where the objective is minimization the cost of distributing a product from a number of sources or origins to a number of destination. Generally in the business or an entity, a product is manufactured, finally it will reach to the end customer. So while reaching to the customer, definitely it might have gone through so many situations that particularly a transportation of to move the goods is one of the important role is transportation. So with using the transportation, we can find the optimum transportation cost and schedule. Cost to be minimized, schedule is a possible route, best solution you will get it. So unit transportation cost is the cost transportation 1 unit of the consignment from origin to destination. Right, we are going to find out about the cost, whatever is so many alternatives it will be there. From the alternatives we are going to find the best solution with using the operations research in these transportation models. So purpose of transportation problem is one of the most frequently encountered application in the real life situation, because in every business transportation is involved from one place to another place. So to deliver the goods, either raw material or the completed goods, to deliver one place to one place, definitely we should minimize the cost with using the linear programming problem. So this linear programming problem, in the first unit, the basics we might have completed. The continuation, this is a special type already I told. So this transportation problem indicates the amount of consignment, the transport from various origins to different destinations we will take. So to be minimized the cost. Objectives of transportation problem: to determine the transportation plan in a single commodity, because for one goods, one commodity means one goods from one place to another place, you are taking the goods from origins to destination of a particular commodity from a number of sources to the number of destinations. Here we are going to find the total cost to be minimized in this shipping. That is, we are going to find, right, different types of transportation. Here we have seen here in the pictures here so many types of waterways, airways and roadways. So many it is to transport goods from one place to another place. So we have to use the applications, thousands of applications, many applications you can see with using these transportation models. So to compute transportation route in such a way to minimize the transportation cost for finding out locations in warehouses. So there it will be minimized the shipping cost. So to minimize the shipping cost from factories to warehouses, so this is we will use the transportation to determine the lowest cost. To determine the location, shortest location or optimal location, we used to find the cost for that particular location, we will use the transportation model. So where it started, actually the operations research topic, this transportation in the earlier days, olden days, the military units, their war related equipments and all, to ship one place to another place with using the military distribution system. So a war to be declared means first they will see the logistics and this transportation system, one place to another place, how many days that whatever they are using, that it will come based on that with the shortest route and which minimizes the cost, like that you will get it. Here you might have seen here about sources, the sources to destination. This is a simple network. Here node or vertices we used to say. Here you might have seen the supply one place to where the demand it is there. This is the source 1, this is the source 2, this is source 3, like that. You can some supply points you can make it, demand points you can make it. So from one supply to demand place, if you want to transport some entity, it will take some cost. That cost we cannot supply 1 to supply 2. These transportation models will give the solution to transport the goods from supply to demand stations only. So here very clearly it is given, the network is here. So in this network, this is a vertices 1, vertices 2, vertices 3, it is there. So here demand 1, demand 2, demand 3, it is there. So this it represent unit cost for the transportation from supply 1 to demand 1 to it reached to from supply 1 to demand 1, the unit cost is 8. Like that, here 3 sources are there, 3 demand points are there, totally 9 possibilities are there. So out of these 9 possibilities, whichever is the best solution we can able to find, which minimizes the cost. So like that, we have to choose the solution among the 9 alternatives we have to choose. The same thing, we are bringing this one into the form of the matrix form. So the same network diagram, it is into the form of the matrix form. So here different problem actually. Here 3 sources it is there, 3 demand stations are there. Here 4 sources and 5 supply, 4 sources are there, demand points are 5. Maybe 4 sources and 5 destination, totally 20 possibilities are there. Among the 20, whichever is the possible, that which minimize the cost, we can able to find out. Right. This with using this matrix, we can find the minimized cost. So the mathematical model we can able to see. So origins is given here, destinations is given here. So that origins and destination we can bring into a mathematical model. So where this is an objective function, the entities will bring into the maximization or minimization. We can write it here. Maximize or minimize the objective function, we can write it. We can combine all the origins to destination, whatever the alternative solutions, that it is I means 1 to 4 and 5 destinations are there, totally 20 destinations alternative we have to choose from that. So here this is related to the source, this is related to the source, whatever is given here. So this is related to demand, whatever it is given here, 4 into 5, totally 20 sources are there, 20 alternatives are there. So again, the transportation problem, it is divided into 2 types of that. Basically, one is a balanced transportation problem, another one is unbalanced transportation problem, where we can able to find the balanced transportation problem where the supply and demand. So a transportation problem, if it is here, so we can able to find this is a supply 1, supply 1, we used to write it, this is supply 1, this is supply 2 and supply 3, like this. This is a destination 1, 2, 3. So here that particular solution it will be there, these solutions it will be there. Totally here the balance, suppose this total it is coming 100. So this total also should come 100. Then we used to say that the first model, it is a balanced transportation problem. Suppose this is 100, suppose we got this is 90, both are not equal. So it is not a, it is an unbalanced transportation problem we used to say. Right, phases of solutions of transportation problem. So for every problem we can able to find the 2 phases. One is the basic feasible solution, another is a optimal solution. So basic solution means we will get the initial solution. Initial solution means that is not final. just some approximate solution you will get it. That is called the initial basic feasible solution. What is an optimal solution? Optimal solution means that is the final. More than that, there is no other option. Definitely you have to identify the solution with using the optimal solution, right? In the transportation problem, there are different models to find the initial methods or optimal methods. First method is the northwest corner method, row minima method, column minima method, least cost method, Vogel's approximation method. Different methods are there. We cannot use all the problems at a time. Based on the task, we can able to find the method with using the transportation models. Right, about this is the introduction we completed, then break for questions. So in initial basic feasible solution, transportation algorithm, we minimize time taken, partial cost, total cost, variable cost. So we think and we have to write as a solution. It is a, so IBFS is a transportation to minimize the total cost. We are using this model for the total cost. Answer is total cost. Next, transportation models used for minimizing the transportation cost of from origins to destination, goods, products, shipping and items, which we are going to taking from origins to destination some entity of goods. So that's why we used to write it as a entity of goods. So this is the answer for entity. So finally, we learned in this about the transportation models, formulation of transportation model, different types of transportation model, what is initial basic feasible solution, what is optimal solution. So these are the things we learned in this presentation. Thank you.